Distance is the length of the entire path. If an object moved along the spiral path, then the displacement would just depend on the initial and final positions, but the distance would be equal to the entire path length. Taking an example from straight line motion, if this particle moved back and forth multiple times, then the distance would be equal to the entire path length. So let's take an example. Suppose we have a particle which starts off at position x1 and then moves in a path up till position x2, but it goes back and forth multiple times. So it reaches x is equal to 5, then it turns around, reaches x is equal to minus 2, turns around again, and then finally reaches the end position. We can break this path down into multiple subpaths, and the first subpath which we take is from the initial position to this position, which is x is equal to 5. And the reason we take this as the first subpath is because the particle is moving along a single direction throughout this entire subpath. Since the particle moves in a single direction throughout this entire subpath, which is this way, we can calculate the distance of the subpath as the magnitude of the displacement. We couldn't do this if the particle wasn't going in a single direction. So if we took a subpath where the direction was changing, so after reaching the end, it would change direction, then the displacement would depend on the initial position and the final position, so this would be the displacement. But the distance would be the length of the entire path, so it wouldn't be equal to the magnitude of the displacement. For the subpath from position x is equal to minus 3 to x is equal to 5, we can calculate the distance as the magnitude of the displacement. So that would be equal to the final position minus the initial position, which is equal to 8 meters. For the next subpath, the particle moves from position x is equal to 5 to position x is equal to minus 2. The magnitude of displacement is again the magnitude of the final position, which is minus 2 meters, minus the initial position, which is 5 meters. The magnitude of this is equal to the magnitude of minus 7 meters, which is 7 meters. The final subpath is from x is equal to minus 2 meters to x is equal to 2 meters. We calculate the distance of this subpath in the same way and add it to our overall distance, which is 19 meters.